Hi there. Let me give you some hints for this practice question. So if you haven't read the question first, please pause the video and read the entire question. Read the setup, take a look at the picture, read the description, and then read both parts of the question, part A and part B below it. Pause the video and read them both at least once, and then we'll take a look at how to get this started. So essentially what's going on here, you have two trains that need to use the same track. So you have a train X that goes from Bull Snake this direction, and then you have a train Y that's heading from Diamondback in the opposite direction. So clearly that train heading from Diamondback has to cross to the other track before X can continue. Otherwise, they're going to crash into each other. So some important information here. X's time to get to Copperhead is distributed normally. So this is notation that I would want you to know. Its mean is 170 minutes. And its standard deviation is 20 minutes. Similarly for Y, the time that it takes to get to Copperhead is distributed normally with a mean of 200 minutes. And a standard deviation of 10 minutes. And something very important, the two travel times are independent. We are making that assumption. So our first job is to find the distribution of y minus x. So we've done this before. So this is going to be a distribution that is also normal because it's a linear combination of two normally distributed random variables. So what you need to find are the mean and the standard deviation. So remember, to find the mean of y minus x, we would simply subtract our means, the mean of y minus the mean of x. So what's especially important, though, is to think about the variance. Remember, you can't just work with the standard deviations. You have to start by working with the variance of y minus x. So, and because these are independent times, you can add the variances together. Remember, even though we're taking the difference of y and x, the variances will still add. So in order to ultimately find the standard deviation then of y minus x, you have to start with the variance, and then you can take the square root of that result. So the first thing to do is to find the distribution of y minus x. And like most AP questions then, you're going to recycle what you've done in part A to answer part B. So what the question says, what proportion of the days will the train from Bull Snake, so the train coming from Bull Snake, that's X, will it have to wait at Copperhead for the train from Diamondback to arrive? That is train Y. So understand in a practical way what's going on. If X gets there too soon, it's going to have to stop in order for it to wait for Y to get there and pass. So if X gets there before Y, that's the proportion of the time we want to find. What proportion of the time will X get there before Y? That's a comparison. So X will get there first if X's travel time is less than Y's travel time. Now understand, we took the time and the trouble in part A to find the distribution of the random variable y minus x. So you should recognize that we can turn this into an expression that involves y minus x. We can subtract x from both sides of this inequality, and we can turn this into 0 is less than y minus x. Or you could turn that around and also say that y minus x is greater than 0. So essentially, what you need to find then is the likelihood of this outcome. The likelihood of this outcome will give you the proportion of the days that the train from Bull Snake will have to wait. And that's something that you should be able to do using what you have accomplished in part A, because you have the shape, you should be able to calculate the center and the spread. You can probably use some z-scores and the normal density function here, and you should be good to go.